Okay, great. So the first thing we have to know actually is the context of where to write. Remember that we are implementing only C++. Are you able to see my screen, please? Okay, great. So here it is. Here it is. So remember that we are solving the thing in C++ only. So we have to have a C++ compiler to solve our issues, our codes, our programs, to implement our rules and things like that. So I'm going to use the online editor cpp.sh. This is the editor, so you can use it with me for now, but you can use the Visual Studio on your local computer, which is much more better. So for now, let's use this one as first class to explain you the purposes, and later on you install the Visual Studio on your computer, on your local computer, and if you have any issues, you just annotate that and raise that, please. So so this is our editor for now. The first tasks, let's solve the same tasks we solved in our lecture this morning. So I'm going to use the simplest editor we may think of. So I'm going to use the Notepad only. Very simple. I may use the Visual Studio also. What is the Visual Studio to write the code? But as I said, I'm going to use the online only, just for easiness of implementation, and not complicate the thing. So online, since we are online, so let's use this online tool, no more or less. So Notepad, just to annotate what I want to do. So immediately today, actually, we explained the context of the functions, and we said that those are methods only, and we said that they are having to have return. So we have some relationship between the context of the methods and the functions in all cases. The program we did this morning, it was talking about the hello Fox, let's say hello Fox program. I do not need the strings library, only the IO stream, and I'm going to use a global namespace library, std library. So خلاص, and then after, my program will be doing all the necessary here. This is the default program of the CPP. I'm deleting and I'm adjusting. The hello Fox program actually is simple. I'm going to just refer to the cout, and I'm going to mention whatever you want. Less than, and then del. It's a capital and small here. Okay, that's it, finished. Well, this is my program. I'm done. Just let me test. It has to work without any issue. There is a problem in my connection, or what? Refuse to connect. Yes, okay, I have an issue. So name space is a spelling, it's typo. Okay, hello Fox. It works very fine. It works very fine. Very fine. So there is no issue at all. What is the relationship in between this and the context of the methods? Remember, we are using main here. Main is it's a method. I'm using a method, but this is actually a keyword method. If we change anything here, I'm going to change, for example, mains in plural. Reduce, run again. Main is not actually something that has to be recognized, but it does not have to give me an error. Here in this case, it is giving me a sort of an error and warning. So why? Because it has to respect the rule, the return. Since I'm saying that it is int here, it has to give an return. I'm changing it to void. Actually, still I have actually an error, which is the lack of the main. The lack here, the lack of the main. I have to have a main, otherwise the program will not run. As per the theory we saw this morning, that the absence of the main will not give an error. Here it's only a process, but to respect the syntax of this compiler here, we have to give a main. There is no error, syntactically speaking. Here there is no error. It's a necessity of this compiler to call the main method, otherwise there is no error at all. So because of this only, I'm rewriting the main without this s. So what is the void main? Okay, again, it's another necessity to respect the syntax. This compiler has defined that the main has to have a return with an int. So I'm respecting the syntax of this compiler only. It is not a C++ program here problem. It's the compiler problem. The error is indicated at this position. It is saying that I have to have a return, and it has to have an int as a data type. So I'm going to return it back to an int. I'm obeying to the compiler necessity only. Run again. Hello Fox again. That's fine. So now we know what is this the behavior of this compiler. Now we know the behavior of this compiler. Okay. I'm gonna make the thing actually a little bit more complicated. I'm gonna just define another method. I'm gonna say void let's say message. I'm starting and closing. Let me do it differently. Here I'm gonna declare here is declaration only. Okay, and I'm gonna here make a call. I'm gonna make a call to this method only. So what should I do? I'm gonna just call the same name message semicolon method call. Simple. Method call here. I'm calling the method, whatever the process of the method here. So the content, the process result of this method would be mentioned here. It's a message. Instead of writing it here, see out hello Fox, it would be provided by this method, by this method, yes, here. So declared here. After the main, I'm gonna do what? I'm gonna define it. It has a start, it has a close, in between my message, my hello Fox. Good, see out hello Fox. Compile. I have an issue with curly braces and semicolons. Let me check what's there. First of all, variable of field message declared void. That's good. That's good. Here I'm declaring it as void, and I'm calling it here. Yeah, there is no error. It's not here. It's not the problem. Declared as void. Expected curly brace to close before the semicolon. Again, it's a compiler issue. I'm going to change this one to, I'm going to say cha. Again, cha. Cha message redeclared, he said, are different kind of symbol. See, this is the problem of the compilers actually, because of the usage. Let me make it simple. I'm going to use an int. Come on. And now if there is any error, it would be actually clear for us to fix. Okay, redeclared define symbol. Previous declaration int message. To avoid any error is appearing to me because of the compiler only, I avoid. So I prefer to start a new interface. It's the context of compiler only, so just avoid it. Simple. I'm going to declare a new method. I'm going to just make the same example we saw this morning. Let's say summarizer or sum declaration. Method call here. the same name, sum semicolon, and definition. Int is an int. Start and close. Int a equals, let's say, 5. Int b equals 10, and then after the result, int res equals the a plus b, semicolon. This sum here, it has to give a return, since it is having a data type int, so I have to provide a return here in return. Give me a second, please. سيف اخبارك وعلومك وحالك وحوالك، عاش من شافك، لاباس، امورك طيبه. الحمد لله، صلى الله عليه وسلم. شكلها ما بيرجع، لكن مستعجلين على تشلوه انتم ده. خليله الشغل، والله هو بيرجع هو راه. جميل جميل، اعطيه. اتكلم على الاس اس دي انت، اعطيه لانه الشغل اعتقد ما في الاس اس. عنده اثنين هناك، امورك طيب اذا. صلى الله عليه وسلم. حتى لو اذا حصلت شغل حطه على جنب. تم الكلام. تم. لا هذا اكسترا بينحذف. صلى الله عليه وسلم، صلى الله عليه وسلم، صلى الله عليه وسلم. So let's resume, please. Since it is have an actually data type in int, we have to have return. Simple return the same variable name, which is making the result, semicolon, and this sum here, which is this method here, I'm gonna bring it in a cout. The sum is, or the addition is, or something like that. Expect the syntax only. Shall I make a new line? No need. Leave it like that, because it's only one statement here. We do not have another line, so just avoid that. No worries. The sum is 15, he's saying. So I can add the new line here, indicator int L here if I need, but no need for now. Okay, there is no issue at all. The context here, actually, just to subdivide, to clarify the subdivision of this code here, we have first part, and the header we declared, and the header, all of this block is the header here. We declared that we are having an object, which is a method that has a return this one, which is a data type to be it's an int. We have a body, the main, and we have actually a queue here, or the termination of this code, which is the definition of what we declared earlier. The program will go from the first line, second statement, third, fourth, and so on. When he comes to this line where it is here, and he will find this call here, he will know that there is something called sum, and it is true available. Later on, the process, he will come. This is the result. I'm going to copy the same code fully. I'm going to copy. Open a new, let's say, interface. I'm going to paste it here, delete, paste. I'm going to define it differently. See here, what I declared here, I'm going to cut what I defined, sorry, not declared. Under this declaration here, I'm going to paste. So declaration, then after immediately definition, and then after the main. Any problem here? So far, no. But we are making actually no need declaration. So here, it will not give us any error. Yes, absolutely. But here, if you write me something in an exam this way, it is not acceptable. Why? Because why you are declaring it to define it? No need to declare it here. This one is not needed completely, because we are defining the method immediately at the place of the declaration. So this one we can omit. I can either delete or change it to comment. So here it's comment. It's not read only by the at all by the compiler. If I execute the same result, and if I delete it even, see here, if I delete it completely, run the same result still, because we are defining. So the difference here, we are not having a declaration, we are having a definition immediately. There is no simple in some semicolon like in here, in some semicolon. We do not have it completely. See, I'm going to change this one to a command. Compile, run, error, was not declared. Nothing is recognized as the name here. Some it's not recognized. This is not here it is available, but it comes after the call, which is not acceptable. It comes after the call. It's not acceptable. It has to be declared to say, hey program, there is something, there is an object named sum, so just pass it. Don't make any error, don't give any error here in this level. Thus, what should I do? I have to return this declaration here and compile again. Very fine. There is no issue at all. Okay. This way, actually, we declared this way or whatever. We declared and we used a method which is said a non-parametrized method. Non-parametrized method. Here it is definition of a non-parametrized method. Definition of a non-parametrized method. Come on, non-parametrized method. Great. Why? Because we are just making a name without parameters here, and between the parentheses there is no parameters. See, I'm gonna just copy this same. No, not this one. I'm gonna use the weather declaration. This one, the more clear one. I'm gonna open a new compiler, new interface. I'm gonna delete this one and paste. Okay. I'm gonna change the process by defining a method that has parameters. I'm gonna change the name, leave the same name. There is no worries. I'm gonna use a first parameter and the second parameter, int, 2 ints. I'm going to use 2 ints. The comma here, this comma here, indicates that we are having parameter number 1, comma, parameter number 2. If I add a third one, so comma, the data type you want, int or char or string or whatever the parameter you need. In this context, we are making the sum, the addition. So we need ints or floats or decimals or something like that. Two ints. What does it mean? Whenever we mention the use of the sum here, we have to respect that they are. It is parameterized here. Declaration here of a parameterized, let's say here, method. Parameterized method. Great. So 2 parameters. Here also have to be 2 parameters. But here is the call. We have to represent the parameters with values. الأولى, it has to be an int. I'm going to say 10. It's not here. Here, let's say 10. The second, also it's an int. So also I have to mention here an int. Let's say 7. So 10 and 7. Call. Very simple. This is in the declaration. Only data types. In the call, real values from the same data type. In the definition here, what we have to do, the same data type plus a variable name. Let's say A, or let's say X, or whatever, any data type, any variable name. The second one, the same data type also, and a variable name. So same data type int, same data type int, and plus variable name, Here we declared the A here on top, so no need to declare it, no need for declaring it. The same, we declared the B, here it is declared int, so no need to redeclare it. Here it is, no need. The res, okay, we have to declare it somehow. Yes, we have to declare it if we need to use the variable to store the result. Otherwise, we may make it actually direct in the return. Full stop. But remember, When we called the method, we passed already values, passed by value here. So the method is being called, plus the values are being passed. So why should I re-change the update the values? We do not need. We can, but we do not need. The A already has been passed here. We represented the A here, the first parameter, with a value. So why should I change it? I do not need this one. So delete. The same for the B, the second parameter. It has been called with a value. So why I have to re-update it? We can, yes we can, but we do not need also, since we did it already. Class. We only have this res, and even this res here, we do not have to have. We can. It's not we cannot, but we can actually make the same process here directly in the res. Sorry, in the return. So even this statement here, we can omit. Only we have a return here in this method. Only return. So only one statement. What it would be the result? Something which is the same. The sum is something. It is the same output like this one, the same output like this one, but the code is not the same. The code is not the same. Here we are defining a parameterized method. We are passing the method, we are making the call of the method passing by value. It is technically speaking, technically said here, passing by value. And then after the number of statements, it's not the same completely. It's not the same. Here we are having only one statement in this block. And then here we are having 4 statements, but the result is the same. So which is better, 1 statement or 4 statements? Absolutely 1. Time consuming and less complexity even. If there is any error, easy to find here. But if there is an error here, it is not the same way. We will not find it easy like whenever we search 1 statement. So this is actually a view via which we can see the methods in action. We are using the word methods, and sometimes I use the word function because of the return only. I'm going to solve the same thing. Actually, I'm going to solve the same thing, but not using a function to make you understand. We said a method because it's a process. It has, see, the sign of a method is the use of those simple parentheses. This is a method, this is a method, this is a method. All of them, they are methods. But we say that it is a function because of the return. Since it has a return, not empty, not nothing, not void. It is a function. It has a return. I'm going to just create a procedure now. I'm going to copy. I'm going to create a new program. The same solution I'm going to go for, but solving the thing using a procedure. I'm going to delete, paste. I'm going to use simple example of program, example of procedure. Here I'm going to say example of procedure. Of, not if, of procedure. Same. we need to have the same output, but using a procedure only. I'm not going to change the main to be a procedure. I'm going to keep the main as such to avoid the compiler issue. I'm going to change this user-created, user-defined function to a procedure. To do so, without thinking, it has to have a void data type in return. It has to. Otherwise, we do not talk about procedure. If it's not void, it's a function. If it's void, it's a procedure. Why? Because the void will not have a return. Since we declared it here with a void, we have to define it here also with the same data type void. Finish. This is a procedure, and this is the definition of this procedure. But since it's a procedure, the return has to be deleted. We do not have a return with a void. We do not have a return. Let's compile and see. Int main, no much for operator, I don't know what, basic upstream and so on, blah 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 blah, whatever. I will not waste time. So here, clearly the error is in this sum, and clearly the error is in this res here, this return here. Very clear, very neat. No doubt that the issue is in this context of sum here and here. I'll start by fixing those 2 errors by deleting this return and changing it to cout res. Simple. There is no return now, there is a cout. Okay, The error here has been disappeared, but still one error here, which is here in this C out in this main. What's the problem? How can we fix? Can we suggest a place? Simple, simple. Here actually there is no C out because already we have a C out here. So I'm gonna delete this C out completely and leave only the sum without anything. Nothing. There is no C out here at all because we have it here. I leave only the sum. All what it was before, I delete it. Here it is, and leave only the sum. Let's compile again. 15. What is the 15? Here it is. I'm gonna just add the phrase here. The sum of A and B's res. Compile. The sum of A and B is 15. Same result, huh? Similar. Let's say the sum is, let me change, the sum of A and B is sum. So we are getting the same result. Here we are using a function. Sorry, what it is. Here we are using a function. But here we are using a procedure. Completely different. Procedural programming, functional programming. Methodology is not the same. The main is the same. We are using a main program. Without a main, there will be no output. Remember that. Let's manipulate the same procedure a little bit more deep. I'm going to copy this full procedure, this full solution here, to create a parameterized procedure. A parameterized procedure. So new interface. I'm going to paste example of parameterized. I'm going to say parameterized procedure. So what should I do? I have to pass parameters to this procedure. At the declaration, let's say here I'm going to say int, and the second one is also an int. Or let's say double, for example, here double. Something like that. I suggest only. The same way here, I have to pass what? Real values. When we call, we have to represent the parameters with real values. Real of what? An int and a double. The first one is int. So I'm going to say, for example, 10. The second one, comma, the second one is double. So I'm going to say, let's say 5.0. 5.1, 5. Whatever. It's a double. So respect the double syntax. خلاص, finish. The same while defining, declaring, calling, and defining the same thing. Here, the same data types, int and double, but int and double, but int, it has to be with a variable name. I'm going to say a, for example. They are only examples. They are not short. You can change the a with any other. Okay. The first one is a, so here it is the a. Again, declared. The second one is b. Here it is. But here it's int. So I'm going to change it to double to respect. To make here. Let me. There are issues here. There are issues, but let me just execute. Void sum in double. Error declaration of int a shadows a parameter. It hides something. Actually, it has something. It's saying that shadows a parameter. Simple here. I'm gonna change this res to double. Why? Because the sum of an int plus a double, the sum of an int plus a double, it can be only a double. It cannot be an int, whatever, because whenever we mix the int with a double, it will be a double. Simple. So I'm going to change this one too. The result would be a double. Execute and see the result. Void still sum in double. The first, he's talking about the declaration here. Int, do that. Error declaration of int I shadows a parameter a parameter. See here the message. Int a shadows a parameter. That's good. So here, because we declared it, the int, I'm not going to redeclare it again. Delete. Let me run again. B, the same message. the declaration of double B shadows a parameter also, the same thing, because we declare the B here. So avoid the declaration. The sum of A and B is 15. The sum of A and B is 15. The sum of A and B is 15. Here, I'm gonna change. I'm gonna actually remember that we define the value of the A. Here it is. We define the value of the B. Here it is. We can. There is no error. It works very fine. Because the last value, I'm gonna change this B, for example, to be 7. So the last values will be utilized. Remember, there is no issue at all. 5 plus 7 is 12. So there will be overridden. They would be overridden. That's very fine. But no need to write them here. If we want, we change here or here. Simple. I deleted both of them. Let me try. Still, it works very fine. 15, which is 10 plus 5. Again, I can minimize also the solution by making the process, this A plus B. I'm going to make it here. See, I'm going to paste and we will see if it will work or not. This one, we do not need it now. We do not need A plus B. I said A plus B immediately. This is the A and this is the B. A plus B. That's it. One statement. Run. Very fine. Very fine. So one statement only. And the same result here. The same result. Parameterized procedure. Following the procedural programming to have the same result at the end. This one or this one. So this is a non-parameterized. Let me write it here. Non-parameterized procedure. And here it is, a parameterized procedure, but the results, they are the same. The same thing here when we talked about the functional programming. Non-parameterized procedure, where it is. Yeah, here when we talked about the functional program and we declare the function here, we define the function here, we call the function here. The syntax is not the same, the solution, the way is not the same, and non-parameterized here, parameterized here, differently, yes, and the solution is the same usually, the same output. We get the same output somehow. Let's make the activity a little bit actually more long and more complex and more coherent. Let's make the math operations, all of them. Let's solve the 4 basic math operations, the addition, subtraction, division, multiplication, using the parameterized and non-parameterized functional approach. Let me copy this code. It's not long. I'm going to use this parameterized based, first of all, copy. I'm going to open a new compiler interface, delete the full here, paste. Here I'm going to say basic math operations using parameterized functions. Great. First method is sum. I'm going to just change the comment also. Addition parameterized method. I'm going to see what I'm going to do. Copy, paste 4 times. I'm going to say here subtract, addition, subtraction here, subtraction, parameterized method. Multiply, multiplication. Multiplication parameterized method. Here divide, division parameterized method. Division parameterized method. Here I'm declaring 4 parameterized methods. The first one named sum, the second one named subtract, the third one multiply, the fourth one divide. Definition, those are declarations only. Definition, the same way. I'm going to copy this block, copy, paste. For the second method, subtract, I'm going to copy this name here. I'm going to paste it here. Subtract, what we'll do? Subtract minus. Simple. Then the third method, copy, paste here. I'm going to change this one with the third one. Who divide? No, multiply. Sorry, third one, multiply. Paste it here. Multiply, so multiply here. Simple. Fourth one, I'm going to copy. Last one means paste to be replaced with the divide method. I'm going to copy, paste it here. What does it do? A by B, division. Simple. Now, what is missing? Output only. Methods call. All of them here. I'm going to call the first one, which is the sum. Then the multiply, then the division, whatever, 4 of them. The second one is the subtract. The subtraction is, I'm going to copy the name of the method. Copy, paste it here. Then multiplication is, copy, multiply. Here, yes, paste, great. Then the last one, which is the division. Copy the divide here, from here to paste here. Done, we did it. We called all of them. See the code here, how it looks like. Very fine. Let me test the compiler. Now let me run my code, my solution. The sum is 17, subtraction is 3, multiplication is 70, division is 1. It works very fine. It works very fine. Why? It is shown to me, all of them, the solutions in one line. Just I have to add the termination of lines, which is the indicator end of. And see what I'm doing, the endl after the call of the method, fully. See what I'm doing. Execute. The sum is 17, the subtraction is 3, multiplication is 70, division is 1. Very clear. I'm gonna move the same solution. I'm gonna move, I'm saying, this solution from being functional based solution to a procedure based solution. Copy the full solution. Copy. New compile interface. Delete this one. Paste. It is not a function. Functions, a group of functions is procedure. They are procedures. Parameterized procedures. I'm going to use parameterized procedures. It's okay. To make it short, we can use non-parameterized, but for now, let's go for the short and the brief solution, the clear. Procedures, without thinking. Data types, they are void. Void. And void. And void. The main, no. The main will remain int. We not touch because of the compiler necessity only. But we can change it in a regular program. We can change it to void. But here we need to respect it to be an int only. Okay, خلاص. Declaration has been mentioned as procedures because they are void only returning. They do not return anything. The same way we have to respect here. Declared as void, so to be defined as void. Declared as void, it has to be defined as void. Declared as void also here. The last one also we declared it as void, so we have to define it again as void only. Simple. If you need something, you speak, please. Later on, you can ask. Leave me finish actually the record, and I'll give you the record, and later on, if you have any questions, you can ask. Great. So procedures. Finished. I finished. Any other points to do? Yes, there is something to do still, but let me test first. Errors int main, nothing. But it's not in the main itself, the error. The error is here. What is this call? The error is here. What is this call? The error is here. What is this call? What is this call? And then after here, return. Return. What's the problem here? A void does not have a return. A void does not have a return. Does not have a return. Voids, they do not have return. Remember, we are talking about procedures, not functions. Great. What should we do? Immediately, without thinking, I will not touch this one first. I'm going to start by here. There is no return. I'm going to replace this return with a cout. I'm going to replace with this return also with cout. The third one, I'm going to replace this return also with cout. And also here, I'm going to replace it with cout. So we have errors. Let me test. One. Less errors, but still we have errors here. This call here. This call here. What's the problem? We do not have a return to put it inside the cout. We have the cout already here. So the full cout here I'm going to delete. The full cout here I'm going to delete. Again. Still here also the cout I'm going to delete. And still those the endl, they do not have to be available. There is no endl. Still, I told you. Delete. Delete. And delete. Still here also. Yes, simple. Just the method to be called with the values. Execute. Same result. We have actually here cout a plus b اللي هي 10 مع 7 it is 17. I'm going to just put a new line here to make it more clear. endl 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 the last one endl also. Let me compile again. One. Yes. A plus b 17. A minus b 3. A by 7 b by b 70. A divided by b 1. Absolutely perfect. It runs very fine. So we are getting similar results, but technique is different. Here procedural program and procedural approach, and there it's a functional program, and here procedural approach. Here it's functional approach. Okay, great. Functional approach. Results are similar. Results are similar. They are the same. It's not similar actually. I can make the same output here. So the sum is and subtraction is, multiplication is, and the division is. Simple. We get the same results. Same results. Procedural approach. Same results. Functional approach. It's the same. So this way actually we manipulated the let's say the majority cases where we can see functions in action. We will proceed still the functions to be declared and to be defined in different ways when using other objects and other object-oriented related components like the pointers and the addresses and things like that. We will see them in future inshallah. I'll stop. I'll give you the record and just immediately I'll give you the record and just